Okay, here we are. We're in chapter 1.4 and we get to solve equations today. So we ought to, as before, make sure we're getting vocabulary straight first. So let's start with the basic definition of an equation, and we're going to say it's basically a statement rather than a phrase. We now have a statement, like if it was in English, you'd put a period at the end. But here we have two expressions that are equal, so guess what? You're going to have equal signs now. So here you go. Equal signs are important for equations. So, and we can solve these. We learned about expressions. Let's talk about solution. Okay, so we have a solution. It is the value for the variable that makes the equation true. So the left side will equal the right side when you choose this value for the variable. So it seems really simple, but we've got to get the language straight. We can't forget what we're doing. Alright, so let's talk about how we solve things. The whole trick to solving things, of course, is to isolate the variable. Okay, so if we only have one variable, we're going to isolate that variable. And you're going to hear me use that word isolate over and over and over again. For those non-English speakers, isolate, of course, is, get it all by itself, okay? And the way we isolate things is by undoing, okay? So how do you undo multiplication? You divide. How do you undo addition? You subtract. Those are inverse operations. They will undo it so the variable can be isolated. So, for example, x minus 8 is equal to a negative 10. This should be an easy one for you. I'm expecting you can do these. But we'll get the language straight. I'm going to undo. I want to isolate the x. It's the variable. And I need to isolate it so this minus 8 is in the way. I'm going to undo it. It's subtract 8. And I undo it by adding 8. Okay? Some of you don't put the equal sign in the middle. That's fine. Here we go. What's left is x is equal to, add the right-hand side together, negative 2. Okay, so the solution is x equal negative 2 because then the left side would equal the right side. Okay, here's a problem I want you to try. 12b is equal to 18. You're going to do the same thing. You're just going to undo 12 times b so you can isolate b. Pause it. So of course, to undo times 12, I'm going to divide by 12 both sides of the equation. That's what's making everything work out, is that I'm doing it to both sides of the equation, so everything's cool. And don't forget, you do need to always reduce your fractions, of course. Alright, so now let's move on to multiple steps. And the idea with multiple steps is there could be lots of different things you have to do. Like maybe you need to combine like terms before you isolate the variable, and then, okay, so maybe that's what's going on here. So let's try an example. Next page. Okay, so here I want to solve for y, and I'll need to combine all my like terms, and I'll have to do that by starting to distribute. So distribute the negative 2, and now I can think about combining like terms. So the y's has a term on the left and a term on the right. I want to combine them. Most of us would put it on the left because that's what we're familiar with, what we're comfortable with. But I'm going to put it on the right. Either side is fine. I like the right in this particular case because it'll make it positive and I won't have another step to do. So let me go ahead and adjust this by adding 2y to both sides. Everything's good as long as I do the same thing to both sides. When I do that, I get 2 is equal to negative 16 plus 3y. And then, of course, I have to combine the like terms of 2 and negative 16. I'll do that by adding 16 to both sides. And what happens in here is 18, 3y. Now I can isolate the variable by dividing by 3. Okay? And what do I get? I get y is equal to 6. Okay? Or 6 is equal to y. It really doesn't matter which way we have our equal sign. And so that is the value of y, which will make this original statement, that equation, becomes true. And of course you could check it, and that's always a wonderful thing to do. So negative 2 times 6 minus 1 is equal to negative 16 plus 6. And let's check and make sure we did this right. I'll take negative 2 times 5 is equal to negative 10. Of course that is true, so we must have done everything right. Okay, here's a multiple step solution solving this equation for you to try. Negative 27 plus 6y is 3 times the quantity y minus 3. Pause it, come back with your answer. Guess what? I got y equals 6 again, but that's the right answer. So hopefully that's what the same you got. And what I wanted to show here a little bit is how you can be a little neater in how much you write. You don't need to write down that you're adding 3 to both sides or whatever's going on. If you can do it in your head, you're good to go. This is as much work as you need to show. Okay, we want to try a word problem. So we're going to use that same being able to relate using our own words. We'll define the variables. We'll write the equation this time rather than just writing an expression. So we have a rectangle with a perimeter of 200 meters. Okay, stop and think. What does perimeter mean? If you remember, perimeter is when you add up all the sides. Okay? Now, what else did they tell us? The length is 3 times the width. Okay? So width sounds like a good starting place. If I start with that, that'll be my variable. Find the dimensions of the rectangle. So I'll need to find the length and the width. That's what dimensions is. So let's start with relate. Use our words. Okay, how are we going to find the perimeter? Well, the perimeter is the sum of all sides. And the sides are, if you want to write it down, the sides are a length, 2 lengths, and 2 widths would be all of the sides. That's another way of saying all the sides. Alright, so then we will simply define the variables, and we decided that we wanted to start with width. So we'll let x equal the width, but I do need something for the length. Okay, so, but the length is 3 times the width, so it'll be 3x. Okay, so now I've defined my variables. Okay, now I will write an equation. And hopefully I'll be able to solve it. So for perimeter, that's what was given, 200 meters. So 200 equals, for the word is, now the sum of all sides, so 2 lengths, so 3x plus 3x, sum is of course adding, and 2 widths plus x plus x. Now some people like the formula 2L plus 2W. Fine, that works for rectangles. Here we go, now I'm just going to go ahead and solve it. So 200 is combining like terms, 8x, x is equal to 25. So now I have to make sure I've answered the question. Of course, that's the most important thing. Go back, make sure you're answering the question. I found x, but I have not yet given the dimensions of the rectangle. So if x is the width, then I need to find the length. 3x will equal 75. Let me put that together. The dimensions of the rectangle will be 25 meters times 75. Okay, or 25 meters by 25 meters. So that gives the dimensions, length times the width. Okay, here's another vocabulary. We want to talk about identities. And the definition for an identity, this is an equation that's true for all values of a variable. So it can be something very simple. It can be something like x plus 2 is equal to 2 plus x. That's an identity. It will be true no matter what value x takes on. Okay? So we're going to play a game like we did in geometry, the sometimes, always, and never game. So sometimes, always, and never, and pick one for this equation. Okay? Let's try this one. Minus x plus 2 times 5x minus 1 is equal to 2, 3x plus 4 plus x. If you want to pause it, go ahead. I'm going to run through it. minus x plus 10x minus 2. I distributed the 2. I have to distribute the 2 on the right-hand side. 6x plus 8 plus x. Let me combine like terms on one side. And then I'll try to isolate the variable, combine like terms, bring the 5 over, and bring the 2 to the other side. 10 over 4 or 5 over 2. And so is that original equation sometimes, always, or never true? And the answer is sometimes. That original equation will be true when x is 5/2. It won't be true if x is anything else. Okay, so that's a sometimes. Okay, so let me try some more. Tell me if this is sometimes true, always true, or never true. Okay, so I want you to tell me, is this sometimes true, always true, or never true? Try that. So the answer here is never, because I was able to simplify this down to a false statement. Okay, it's false. -5 does not equal 4. Okay, so there's no value of x that's ever going to make -5 equal 4. So that's just never going to come true. There's no value of x you'll ever find. Okay, so that's it. And we'll talk about literal equations tomorrow because I think we're running out of time. So that's enough for tonight. See you tomorrow.